Hi everyone, we're going to work on 7-7, solving radical equations and inequalities. I'll warn you, we're going to do a lot of examples so we really get the feel for it, and I hope you do every single example. Okay, so what we're doing is when we're solving radical equations, these are the steps I'm going to be using. So what I'm going to do is just cut them out and bring them with me in the next screens. All right, so what they recommend that we do is isolate the radical on one side of the equation. So let's start with example 1. I'll rewrite it with you so that this is 1a, so that I'm not going too fast. We have the square root of x plus 2 plus 4 equals 7. So we're solving radical equations because square root of x plus 2 is radical x plus 2. So these are radical equations because there's an equal sign. We have to isolate the radical on one side, so it means we want the radical alone, which means we don't want the plus 4. So we start by subtracting 4 from both sides, and we're left with the radical alone, and now it equals 3. Now we're going to raise each side of the equation to a power equal to the index of the radical to eliminate the radical. What? It means since this is implied to be a 2, I'm going to raise everything, both sides, to the second power. If it was the cube root, in order to get rid of the cube root, I would cube all sides in order to get rid of the cube root, etc., etc. So since this is just the square root, I can square both sides, and that will get rid of that will eliminate the radical. So I get x plus 2 equals, and now this equals 9. Then I go ahead and just simply solve by subtracting 2. Now, it's very important, I'm getting an answer of 7. It's very, very important that you check your results. It is not an optional step. It is part of step 3. And why we check, very importantly, and it is part of the problem, is because anytime you square both sides, it's kind of a long, involved thought process, but anytime you square both sides or cube both sides, there is a chance that you just introduced an additional answer, which was not good. And that's called an extraneous answer because it's extra. And when that happens, sometimes it doesn't make the equation true. So you absolutely have to check the work. So let's go ahead and do the check. And yes, I do want to see this. You're going to put down square root of 7 plus 2 plus 4, and you want to see if it equals 7. Well, this is the square root of 9, and I know that equals 3, and of course 7 equals 7. So we're really happy with the answer that x was 7. It was a coincidence that 7 equaled 7 at the end. I just wanted them to equal each other. All right, let's try another one. Okay, right away, this one is more involved. I'm kind of surprised it came up right now. When you have two radicals, what you want to do is isolate the more, let me do that. You want to isolate the more complicated one on one side. And then on the other side, it's okay if you have a radical in it. And so what I'm going to do is square both sides. But this is really particular because if I square this side, I can't square each individual quantity. Now, why not? Well, let me come up with something simple. Let's say that 8 is equal to 6 plus 2. Let's see if this will demonstrate what I want to do. If I square both sides, will this work? This is 64, and this is 36 plus 4. Is that going to be true? Ooh, nope. So just to demonstrate, you can't just square every term across an equation. You have to square both sides. So here I have 64, and here now I have 8 squared. Oh, okay. So I had to square the whole thing, the quantity 6 plus 2. So that's why I square the whole 2 minus square root of x. Well, the left side is going to be a piece of cake. This is what I kind of wanted it to be, simply x minus 12. But guess what the other side is? I hope you guessed correctly. It's 2 minus radical x times 2 minus radical x. The entire quantity got squared, which means you have to square the binomial, which means you have to do what? Are you saying FOIL? That's correct. Wow, I'm so proud. So what we have on the left is still x minus 12, but on the right, we're going to FOIL. We get 4 minus 2 radical x minus another 2 radical x, and then negative times negative is positive. Square root of x times square root of x is square root of x squared, and that equals x. I'm going to simplify by adding like terms. This is just going to be negative 4 square root of x. It's kind of like negative 2x minus 2x. It's just negative 4x plus x. Now what do? To be honest, we go back to step 1 again and we continue. We still have not isolated a radical to one side. So I'm basically going to subtract 4 and subtract x from both sides to move them onto the other side. So I am going to subtract 4 from both sides and subtract x from both sides. Let's see what happens. I get x minus x, so that's nothing. And then negative 12 minus 4 is negative 16. I'm left with negative 4 times the square root of x. And now I can divide both sides by negative 4. So what I get is positive 4 equals square root of x. Now I do step 2. I raise both sides to the power that I need to get rid of my radical. And so that's the second power. So I get 16 equals x. That's my answer. And now I'm going to check. Remember, my check is not my answer. X is 16 is my answer. So I'm going to erase this so that I look at my absolute original equation and I plug in 16. I get square root of 4 equals 2 minus square root of, square root of 16 is 4. So I get 2 equals negative 2. Hey, wait a minute. That didn't work. So what ended up happening is that there was no answer. Because there was only one answer, it didn't end up working, so there is no solution. And I erase this and say, no, Mrs. Brzezicki, I changed my mind. There is no solution. That's a little disheartening, so remember, you have to check each answer. So here, as the book described it, the solution does not check. So the equation has an extraneous solution. The graph this and this do not intersect, which no real solution. Okay, that was confusing about the graph thing. Don't worry about that. But there's no solution. All right, let's try this one. This is more of the simple one that we did as my first example. So go ahead and start that one. Did you start by adding 1 to both sides in order to get the radical along? Okay, you should have gotten 6 equals the square root of x minus 2. Step 2 says raise each side to the power that you need. So basically I had to raise it to the second power. So that gave you what? 36 equals x minus 2. Now add 2 to both sides. 38 is what we think x is. We'll check it. Looks like it works. So again, my answer is 36. I do not, I don't want to put an X through that. I don't circle this. That is not my answer. Okay? X is 38 is my answer. All right, try this one on your own. So now's a good time to pause the tape, the recording, and actually I'm going to pause it too because I think I need some hot chocolate because it's freezing. Okay, hold on, I'll be right back. Okay, so I hope you started by squaring both sides. But remember, you have to put in parentheses. If you want, you can put these in parentheses to feel it. But square root of x plus 15 times the square root of x plus 15 is just x plus 15. Again, why? Because let's say the square root of 17 times the square root of 17 is the same as the square root of 17 squared. And that is the square root of, I don't even know what the square root of 17 squared is. Let me look. 17 squared is 289, so it's like the square root of 289. Oh, that must be 17. So that's why we just get rid of the square root when we square a single quantity. Okay, over here again, we write it as 5 plus the square root of x times 5 plus the square root of x. Now this baffles my mind. Even though I am demonstrating this and writing it out, I still get students who refuse to write out the steps, and they will write this step wrong, and they will get the problem wrong, and it could be half the class, and so I don't understand it. Are you paying attention? Did you hear what I said? And my last question, are you going to be a statistic? Don't be one of my 50%. I'm warning you. You hear the warning. All right, so what do we get? We get x plus 15 equals 5 times 5 is 25, and 5 times square root of x is positive 5 square root of x. 5 times square root of x, so plus another 5 square root of x, and then square root of x plus square root of x is x. We have x plus 15 equals 25 plus 10 radical x plus x, and we move these two to the other side, subtracting 25 and subtracting x. So we get 15 minus 25, that's negative 10. The x's cancel, and we have 10 radical x. Divide both sides by 10, so that we get radical x alone, we get negative 1. And now we square both sides to get x alone, and I think x should equal 1. Let's go ahead and do the check. I think I like the check in a different color. Maybe ink, maybe red, maybe colored pencil. All right, so this is the square root of 16 equals 5 plus 1. 4 equals 6. I don't believe this works. I will say there is no solution. I will check this though, because I don't want to make a mistake. Yeah, no solution. We got the same problem, yeah. Well, there's one less problem to do. Okay, so let's do this one. Same thing, except now we have a cube root. Remember, raised to the 1/3 power means the cube root. So I'm going to start by writing this problem over. I'm going to kind of go slowly so you can write the original. And then I'm going to rewrite it as 2 times the cube root of 6x minus 3 minus 4 equals 0. Now, step 1, I want to get the radical alone. So it means I have to get rid of the 2 that's on the outside and the negative 4. Well, I start by adding 4. Because now I can divide both sides by 2, because this is multiplication and I want to undo it. And that's how we're going to get our radical alone on the left. Now we're going to raise it to the third power. Remember, step 2 says raise each side to the equation to a power equal to the index of the radical, 3. So I'm going to raise that to the third power and that to the third power. So the feeling again, let's look at something simple. The cube root of 8, that is actually 2. And what happens if you raise 2 to the third power? You get 8. So again, the idea of cube rooting and raising to the third power cancel out. They have to be the same number though. So that's how we get 6x minus 3 alone, and that equals 2 times 2 times 2, which again is 8. We add 3 to both sides, so we get 6x equals 11. So I believe x is 11/6. I think that's my answer. Let me do the check. I'm going to do it in another color. So I get 2 times, I'm just going to write it, the cube root of 6 times 11/6 minus 3 minus 4. Does that equal 0? This looks difficult, but it's not. Remember, 6 times 11/6 is just 11 because the 6's cancel. Now we know what 11 minus 3 is. It's 8. And we probably know what the cube root of 8 is. What times itself 3 times gives you 8? That's 2. So we have 2 times 2 minus 4. Does that equal 0? It sure does. 4 minus 4 does equal 0. 0 equals 0. So 11/6 was my answer. Okay. So go ahead and try this one. You can pause if you want. I'm going to rewrite it as a cube root. Should subtract 1. And now we raise both sides to the third power. -1 times -1 times -1 equals -1. And I think is -1. Let's go ahead and do our check. Okay, what number times itself 3 times gives me -1? Oh, -1. And -1 plus 1 is 0. So I'm really happy with the answer, n equals -1. Go ahead and try this one. Again, you could pause it and do the whole thing if you prefer. I'm going to add 2. This is a little big and obnoxious. Here, try this one. That's a little small. Oh gosh, I'm sorry. All right, I'm going back to blue. Divide both sides by 3. And raise both sides to the third power. So we get 5y minus 1 alone. What happens over here? Remember, when you're multiplying or dividing and you're raising it to a power, you can raise each part to that power. So I'm going to raise 2 to the third, which is 8, and 3 to the third. 3 times 3 times 3 is 27. Now I'm going to add 1 to both sides, but to be honest with you, I want to sort of add it in a way that would be easy to add. So I'm going to add 27 27ths to that side, which of course is the same as 1. So I get 5y, and I get 35 27ths. And I'm going to divide both sides by 5, or I can think of it as multiply by 1/5. That way I get y alone, and my 5 and 35 cancel. I get 7 over 27. That's my answer, I believe. And now I'm going to go check. Here's my check. This looks like it's going to be fun. Instead of saying -1, I'm going to say 27 27ths. I want to see if this equals 0. So I get 3. This is, when I multiply through, I get 35 over 27 minus 27 over 27. Does this equal 0? This is 8 over 27. Now remember, I don't know the cube root of 8 27ths, but I do know the cube root of 8 and the cube root of 27. And that's 2, and that's 3. And as you can see, the 3's cancel. You get 2 minus 2, and that equals 0. So 7 over 27 was a great answer. Maybe I would have preferred using my calculator for the check. That would have been understandable. No problem. Okay, go ahead and try number 3. We're going to do inequalities in a second here, which is very similar. So again, we're going to add 12 to both sides. And divide both sides by 4. We're going to raise both sides to a power of 4, same as the index. That gives me 3x plus 6 alone. 3 times 3 is 9, times another 3 times 3 is 81. Subtract 6, 3x equals 75. So x is 25. Oh, and the answer is 25. I would have plugged it in to check it. Let me do that really quickly in red. I like it. 25 seemed to work. All right, now we have inequalities, and let's read the steps. If the index of the root is even, identify the values of the variable for which the radicand is non-negative, because you can't have negative numbers under a radical if the root is even. So you can't have square root of a negative number because we are not working with imaginary numbers in this chapter. We're only working with real answers. But remember, if the root is odd, you can have a negative number under the radical because, for example, what number times itself 3 times is -1? Well, it's -1. So an odd root is okay to have a negative number underneath. So we're going to go ahead and solve the inequality algebraically, and then we're going to test the values to check the solution. All right, so right here, I'm going to go ahead and do my my domain. Always start these problems with domain. We know that 5x minus 10 has to be positive because it's under a radical. So it has to be greater than or equal to 0. This is really important. Now, why am I doing this now and I didn't do it before? Because what's going to happen right now is that my answer is going to be a number like, hey, anything less than 2 will be my answer, or something like that. Well, if I start getting negative values under my radical at numbers on this side, then I will have to not include those answers. So I have to be careful. It's not just one little answer I'm getting. It's a whole range of answers. So that's why I'm going to check my domain first. Okay, I was interrupted because a student came in. I'm sorry if I sound like I was interrupted. All right, so I always start by saying the quantity that's under the radical has to be positive. Okay, the quantity under the radical has to be positive if the root is an even number. So I solve this by saying I'm going to add 10 to both sides. So now I have 5x has to be greater than or equal to 10, and I divide by a positive 10. That's really important because remember, if I divided by a negative number, I would have to flip the signs, the inequality sign. So remember that when you're doing inequalities, if you multiply or divide both sides of the inequality by a negative number, you have to flip the inequality sign. Okay, so far in pencil really lightly, what I would do is say, okay, x has to be bigger than or equal to 2. So it's everything from 2 to the right will work for this. Now, it won't work for the equation. No, these are the only valid x numbers that I can use in this equation because this is the only thing that will give me a real number for this radical right here. Okay, now we actually solve the inequality. So we do the domain and then we say solve. Very important to set this up correctly. And if you don't know those two steps, you will not get your answers right. So what's nice is we do it the way we've been doing it. So again, step 1 is domain, and step 2 is solving. And then we'll test our values. All right, I'm going to start by doing what did we do before? We're going to subtract 3 from both sides. So we get a positive square root of 5x minus 10 is less than or equal to 5. And then what did we do before to solve? We squared both sides. So we were left with 5x minus 10 and now 25. So we add 10 to both sides. So 5x is less than or equal to 35. And to actually solve, we divide both sides by 5. So x is less than or equal to 7. So when I go up to my diagram and I say x's numbers less than or equal to 7, I have to stop at 2 because wait a minute, numbers could not be less than 2. So my answers are x had to be less than or equal to 7, but greater than or equal to 2 based on my domain. This is my answer. In interval notation, numbers 2 through 7 work, including 2 and including 7. That's my answer in interval notation. What was this? This was inequality notation. This is the way we notated it. All right, let's do another one. Let me check that one now. All right. I can check this by plugging in a number like 4 into this and see if it works. That would help. If I was on a test and I was really paranoid, I would then also plug in numbers like 0 to make sure it didn't work and 8 and make sure it didn't work. All right, go ahead and do 4a. Remember to start with domain, and after domain, go ahead and do the solving. Okay, I need the quantity under the radical to be positive or 0. That's because my index was implied to be a 2, which is what kind of number? Even. All right. Oh, I'm going to subtract 2 from both sides, but I really should do it in pen and not eraser. Divide both sides by what now? Positive 2, so that you get the x alone. So did I have to switch the signs? No, because I didn't divide by a negative number. So I get x has to be bigger than or equal to -1. So here's -1, and I know that x has to be bigger than it or equal to. So I'm definitely talking about everything to the right of -1. Now, what happens when I solve? We're going to subtract 1 from both sides. Square both sides. Divide by 2 I mean. Okay, so the answer to our equation is x has to be numbers bigger than or equal to 7. But what does it have to do with the -1? Well, is 7 and above my solution, is that in the yellow zone? Yes, it is. So all I have to do is say x has to be greater than or equal to 7. All of those numbers were valid numbers in my domain. Numbers less than 6 won't work here because it doesn't solve that. And numbers less than -1 will definitely not work no matter which way I look at it. So in this case, I just say x had to be bigger than or equal to 7, knowing that my domain encompassed all of those numbers, and I didn't have to worry about my yellow line, my valid x numbers, my domain. Try this one. Or is this the same? No. So if it's an inequality and it is a radical, you start with domain. So you need the quantity under the radical to be positive. Divide both sides by 4. X is greater than or equal to 1. So that's my domain again. I'm going to graph it in yellow. Then I solve. Add 2 to both sides to get the radical alone, just like we have been doing all lesson. Square both sides, so we get rid of radical, and add 4 to both sides. Divide both sides by a positive 4, so we don't need to switch the signs. X is less than 10. But remember, it's less than, not equal to. Numbers can't be less than 1, so we have to have numbers bigger than 1. So we would say x is numbers bigger than or equal to 1, and at the same time, less than 10. That's inequality form, and in interval form is numbers 1 through 10, including 1, but not including 10, because this was x is less than 10, not less than or equal to 10. So either of these is the right answer. I'll take either one of them, but you just want to make sure that when you check the back of the book, you're getting the problems right. Okay, well that concludes our lesson. If you want, you can try these problems. I'll work them really quickly right now below, just silently. What am I doing?